All right. Hey, everybody. Mr. Ford back here. So hopefully you work through this with your groups. I think I saw a lot of really good group work there and a lot of sharing ideas and figuring it out because this stuff can be hard to see, right? And it's hard to read about afterwards and feel like you really got it. So you got to put in the mental work and got to capitalize on what other people are saying and bringing stuff to the forefront. And then you really get it. And then videos like this will hopefully make sense to you. But anyways, I'm filming this video right here real quick in case you're a little curious about slides 8, 9, 10. And that's it. I got slide 10 here twice. I'll delete that here. But basically, I want to make sure you know how to get the area of these regular polygons here. And then we'll maybe talk about a formula a little bit later on the slides. It's kind of talking about a formula for this. And I don't know if I'll do that today. I might film something for the weekend when you guys have an asynchronous problem. Well, it's a homework, right? So it's not even an asynchronous problem set. It's just a homework on finding the areas of regular polygons, because that's an important thing to get for us to understand where the area of a circle really comes from, which you really should do in geometry class, your freshman or sophomore year, whenever you're taking this class. So anyways, check it out here. Make sure you got this here. Use perimeter area of this polygon to the nearest 0.1 to show your work on the text box in the sketch. So hopefully you got this with your groups, but maybe you're just watching this to check your answer. But if not, on all these problems, you're only given one component of the regular polygon. You're given the radius. Okay, given the radius of the regular pentagon here. So remember, any regular polygon can be inscribed within a circle. So this is circumscribed about it. So here, the center of the circumscribed circle, the thing where the pentagon's inscribed in, this is called the center. Okay, so the center here, I can tick off 1, 2, 3, 4, 5 isosceles triangles because all radii in a circle are congruent to one another. This is the radii of the circumscribed circle. We'll call this the radii, all these the radii of the polygon themselves. So all these are 10 centimeters long. I'll just tick them off because we know that. We also know, because this is a regular pentagon, that all the sides have to be congruent, because a regular pentagon is both equiangular and equilateral, and it just has 5 sides, what makes it a pentagon. What makes it regular, though, is equilateral and equiangular. So the question is, how do we get the area? Well, very sadly, what a lot of people were saying was, well, I know the area for this. I know the area of how to get a triangle at this point in time, okay? I have one side of this triangle, 10 centimeters. So the question is that my base? Can I get a height? What height should I get? Well, remember, these are isosceles triangles, okay? Isosceles triangles. And what do we know about isosceles triangles? Well, if we draw an altitude to the base of an isosceles triangle, so this was key on all of this, all the problems here. I'll simplify it, show them more simply on these slides here. But if I draw an altitude to the base of an isosceles triangle, it creates 2 congruent triangles, and they're congruent by HL. They're right angle because it's an altitude here. So anyways, if this is 10 centimeters long, I have that as a hypotenuse. A lot of groups are thinking, hey, maybe I can use Pythagorean theorem. No. Well, on this one here, you're going to use trig. Okay, use trig. Because what did I have refresh you guys on yesterday in terms of the classwork? Well, the interior angles of a regular polygon here. And what do we know about each interior angle of a regular pentagon? Well, what you studied yesterday, or your refresher on yesterday, is we've got this formula: n minus 2 times by 180 over n. That's how we can figure out what each of these angles measures. So what I'm talking about right here, all the congruent angles, because it's got 5 sides. There are 3 triangles I could create by drawing in 3 diagonals. Notice here, these aren't diagonals. These are radii, connects to the center of that regular polygon. So n minus 2, that's 2 times 180, that's 360, divided by 5, that's 108. Okay, so this is 108 degrees. I know that my radii create 2 congruent triangles here. That means that on this side here, this altitude, draw this altitude here, those 2 triangles are congruent here. So you know what? These 2 angles are congruent by CPCTC. So in the triangle of reference, this is a 54-degree angle. Well, how did I get that? 54 times 2 equals 108, right? 1/2 of 108 equals 54. So I have a 54-degree angle there. I have a 10 centimeters thing there. And you know what? What's my goal? Well, I want to figure out the area of this triangle first, so I can just multiply it by 5, get the area of the whole regular pentagon. This is a good problem. There's a lot to think about here. I can use trig to figure out what my altitude is, and I could also use it to figure out what half of this side length is here, okay? Stay with me here. Maybe I'll put this one here, OC. Oh, we already had an O. Let's put this QC right here, okay? Let's just let this be point Q right here, okay? How can I use trig right now? Well, I can use here to get my altitude here, and I'll do this for A, stands for apothem, right? Apothem, let's say what apothem is this weekend. Maybe I want to explain this to you for your weekend homework. Apothem is an altitude from the center of a regular polygon to one of the bases, okay? So that, and we can think of it as the altitude of the triangle here. So I want to figure out 1/2 A times by DC. That would be 1/2 base times height. That would be good here. But if I can get this, I got the height of the triangle. And then if I get QC, I got 1/2 of the base of the triangle to use. You see? Is it adding up? I don't know. We'll maybe do this one here too, okay? All right, check this one out. We want to use trig. We want to get A. We know the hypotenuse. Look at this here. The hypotenuse is 10 centimeters. Okay, we just don't know A. We don't know what QC is here. So if I want to get opposite side, but I know the hypotenuse, what am I going to use? Opposite and hypotenuse. So, okay, so katoa, okay, I'm going to use sine of 54 degrees. Oops. Equals its opposite, which is the apothem. It's the height we're looking for to get the area of that triangle, over the hypotenuse, which is 10 centimeters. Okay, what do I do now? I multiply 10 centimeters by both sides. Oh, I can do A over sine of 54, right? I got to solve for A. Well, I'm solving A. That's easy enough. I just multiply sine of 54 by 10 centimeters, okay, which I'll do right now. I'll show it to you guys here. So I'm the teacher. I need to show it. Well, you should show your work too, okay? Sine of 54 degrees. Make sure we're in degree mode. Lots of things to double check with here. 0.8, that seems about right. Sine of anything less than 90 is going to be less than 1, so we're good there. Times by 10, okay? And I got 8.09, okay? So A is about 8.09, okay? It wants us to the nearest 0.1, so I'm going to 0.2 for this one here, and also we have a 0 there, so that's a pretty safe thing to round to here. Okay, I got that. And I got, what else do I got? I want to get QC here now. What am I going to use to get QC? Well, I'm just going to use cosine, right? Because cosine of 54 degrees, this 54 degree reference angle here, its adjacent side is QC. So it's half of the length of one of the sides of the regular pentagon here. Cosine of 54 degrees equals QC, segment QC, over 10 centimeters. And we're going to do the same thing. Multiply both sides by 10 centimeters. Cosine of 54 degrees times by 10 centimeters, I got 5.87. I'll go to 5.88, okay? Maybe I'll show more digits here because it wants the nearest one. So maybe because these are kind of in the middle here, I'll be safe and do 5.87785. Okay, anyways, I have that there, okay? So now I can get the area of this triangle. Okay, right, I can get the area of this triangle right here. Boom, I can get that. So the area of one of the 5 triangles, well, that equals 1/2 base times by height. What do we know about the base here? Well, this is about 5.87785. The base is going to be twice that. Okay, my base is 5.87785 multiplied by 2. I get about 11.75. 7557. You notice I left it in the calculator here. That's going to be a more precise answer. Okay, so I just simply do 1/2. Base is about 11.7557. Height is what I got earlier, 8.09. Okay, multiply that by 8.09. Okay, multiply it by 1/2. Divide by 2. Hopefully I didn't make any mistakes. I got 47.45. So that equals 47.55 square centimeters. Oh, look at this. We're in centimeters, right? We're giving that in centimeters. So the area of the whole pentagon equals 5 times area of the triangle. So I simply got to take this and multiply it by 5. Boom, I get my answer. Okay, 47.55 centimeters squared. Okay, multiply that by 5, and I get 237. Okay, equals about 237. 237. Points. Ooh, nearest. Ooh, look at that. We're on the edge here. I'm going to round up to 0.8. 0.8 centimeters squared. Okay? All right, there's first video. I'll film separate videos for slides 9, slides 10 pretty soon, okay? But hopefully that helped you with the process. I'm gonna go a little bit faster on the other slides because I'm hoping you've seen this already, okay? Thank you very much, folks. Let me know if you have any questions. Bye-bye now. I gotta do the teach 7th block.